Here we go with part 2. We're starting off with number 14. 14, ab to the 5th power, 21, a squared, b to the 9th power. So first thing I want to do is I want to take care of my constants. And what I'm going to do here is I'm just going to simplify this. 14 over 21 I know can simplify to, if we divide by 7 on both the denominator and the numerator, I'm going to get 2/3. I have a to the 1st power divided by a to the 2nd power. That's going to give me a to the negative 1st power, or the a in the denominator. The way I did this, if you expand just the a's out, we have a divided by a times a, so 2 of the a's cancel and we're just left with 1 over a. So that's how I found that a in the denominator right there. B to the 5th divided by b to the 9th. Same thing here. If we have 5 b's divided by 9 b's, we have the 5 that will cancel out, and I'm just left with 4 b's in the denominator, so that's b to the 4th power. That's our answer there. Number 15. 16, c p to the negative 4th, q to the 3rd, divided by 24, p squared, q to the 9th. So same thing here, I'm going to simplify these two constants. 16 over 24, they have a common factor of 8. So if I divide both the numerator and the denominator by 8, I'm going to get, again, 2/3. Now, let me erase that division thing there, so we have this. There's a c, just a lonely c. Nothing I can do about that c, nothing I can combine or simplify with. So that c is just going to stay in the numerator where it always was. P to the negative 4th power divided by p to the 2nd power. If I come over to the side here, this is p to the negative 4th minus 2 power. That's going to give us p to the negative 6th power, bringing that p to the 6th power into the denominator. Same thing with the q to the 3rd power divided by q to the 9th power. That's q to the 3rd minus 9th power, which is q to the negative 6th power, leaving q in the denominator as well, q to the 6th power. So there is your final answer there. Next one, negative 11 x to the 7th times negative 9 x to the negative 12th divided by 3 x to the negative 3rd. So I want to deal with the numerator first here, and I'm going to start with my negative 11 times my negative 9. Negative 11 times negative 9 gives me a positive 99. I have x to the 7th times x to the negative 12th. We're going to add the exponents. The bases are the same, and we're multiplying. We're going to add 7 plus negative 12. That's going to give me x to the negative 5th power. And of course, this is all over or divided by 3x to the negative 3rd power. My favorite thing to do right here is to get rid of the negative exponents. So when I do that, I have 99. Let's show you here. This x to the negative 3rd is going to come up to the numerator. X to the 5th is going to come down to the denominator, not denominators. Okay, look at terminators. 99 x to the 3rd divided by 3x to the 5th power. Once we have that, I'm again going to come back here and I'm going to deal with my constants. 99 divided by 3 gives me 33. And if I have 3 x's in the numerator 5 x's in the denominator. 3 of them are going to cancel. I'm just going to be left with x times x in the denominator. So we'll call that x squared. And there is your final answer. Okay, number 17. G to the 4th, r to the 6th, divided by g to the 2nd, r to the 9th. Start with the g's. G's Louise. G to the 4th divided by g to the 2nd. We subtract the exponents because the bases are the same, and that gives us g to the 2nd power. R to the 6th divided by r to the 9th gives us r to the negative 3rd power. When we express that with positive exponents, we get g squared over r cubed, or r to the 3rd. That is our final answer. Number 18, 21 e to the 4th f squared divided by 7 e to the 7th f to the 3rd. I'm first going to deal with my constants. 21 divided by 7 gives me 3. Let's look at e to the 4th divided by e to the 7th. That's going to give me e to the negative 3rd power. 4 minus 7 is negative 3. And then we have, oh, I didn't want to do that. For a second I thought that was a highlighter. That was not a highlighter. So f to the 2nd divided by f to the 3rd. 2 minus 3 gives me f to the negative 1st power. Now I want to express this with positive exponents. So e to the negative 3rd power, f to the negative 1st power. What we say as a shortcut here is cross the line, change the sign. So we have 3 over e to the 3rd f. I can write f to the 1st power, but I can just leave that f alone. That's your answer for 18. 19, your favorites. I think we actually did this one as a warm-up the other day. So 1 over 343 equals 7 to the nth power. We want to find n right here. So what we need to think about is 343 in terms of base 7. So we know, or we can figure out on our calculators, that 343 is 7 to the 3rd power. But we want to know this is equivalent to 7 to what exponent? Well, we know with negative exponents that when there's a negative exponent, we actually bring this whole base with the exponent down into the denominator. So our answer here is going to be n equals negative 3. Next one, b to some power divided by b to the 16th power is going to equal b to the negative 12th. Well, we know that when we are dividing bases that are the same, we subtract the exponent. So this means that b to the n minus 16 power is going to equal b to the negative 12th power. So now we just need to ask ourselves, what minus 16 is going to give us negative 12? The answer here is 4. 4 minus 16 gives you negative 12. Now we have b to what power, all raised to the 5th power, gives us b to the 80th power. Well, we know when we take a power to a power, we multiply the exponent. So this is b, n times 5 is going to give us b to the 80th power. We just need to ask ourselves, what times 5 gives us 80? Well, 16 times 5 gives us 80, or we could take 80 and divide it by 5, see what we're going to get, and the answer is 16. Number 22. 8 to the 3rd power times 8 to the negative 1st power divided by 8 to the 4th times 8 to the negative 2nd power gives us 8 to what power? So we need to figure this out here. I'm going to simplify the numerator and the denominator first to get rid of some of these 8 to the powers. So 8 to the third times 8 to the negative first. Bases are the same, we're multiplying. We know we need to add the exponents. 3 plus negative 1 is 2. Same thing on the denominator. 8 to the fourth power times 8 to the negative second power. We're multiplying. We add the exponents. 4 plus negative 2 gives us 8 to the second power. And we know this equals 8 to what power? I'm going to go ahead and simplify this even further. A couple ways we can do this. We know when we divide that we're subtracting exponents. So this becomes 8 to the 0 power, 2 minus 2. So that means n equals 0. The other way you can think about this, 8 squared is 64. 64 divided by 64 gives you 1. Anything to the 0 power gives us 1, so we know here that n is equal to 0. 13 to the nth power gives us 1 over 169. Well, we know we need to think of 169 as base 13, and we know this is 13 to the second power. 13 times 13 gives us 169. So, 13 to the n power, we know that when we have to get this from the numerator to the denominator, this has to be a negative second power for your answer. Number 24. Same bases, they're all 8s, and we know that we're multiplying. So we know that this is 8 to the negative 4 plus n plus negative 7 is going to give us 8 to the 10th power. Simplifying this a little bit, we have our negative 4 plus negative 7 gives us negative 11. So negative 11 plus n gives us 8 to the 10th power. Negative 11 plus what gives us 10? Figuring that out, that's going to be 21. 21 plus negative 11 will give us 10. Alright, number 25. Order from least to greatest. To do this, we have scientific notation here. We need to make sure that all of our 10 to the powers are going to be the same so that we compare apples to apples. So let's change everything to 10 to the 6th. So 6.9 times 10 to the 6th is already in the 10 to the 6th power. 23 times 10 to the 5th power. Well, what we want to do is we want to change this so that we have this to the 6th power. So this is going to be 2.3 times 10 to the 6th power, and that's going to give us the same thing as 23 times 10 to the 5th power. Same thing here, 72 times 10 to the 5th power. This is going to become 7.2 times 10 to the 6th power. Now that we know they're all in the same powers, we can just compare the constants in the front of the scientific notation. So when we order this least to greatest, the smallest number here is going to be 23 times 10 to the 5th. Then we have 6.9 times 10 to the 6th. And last but not least, 72 times 10 to the 5th power.